All right. The derivative of secant inverse. 1 over absolute value of, in general, u, right? And our u is 3x minus 4 times the square root of, now the thing you guys have to be careful of as you're studying this, is this one u squared minus 1 or 1 minus u squared? Yeah, so we got 3x minus 4 squared minus 1 times the derivative of the inside, which is 3. Now, we'll kind of start getting in the habit of just, since there's a 1 up top, just putting the 3 up top. To expand or not to expand, that is the question. Do not expand. Why? Okay, we always go back to this. When do you decide, how do you decide to not expand? What's the rule we talked about multiple times this year? Good talk. These are the moments I feel like a really good teacher. How we talked about this. Good dialogue. Oh, yeah. Change live. One derivative at a time. What is our goal? Where are we heading with this? This is the derivative. We're eventually going to set it equal to 0 and find out where it doesn't exist. Does this derivative ever equal 0? Well, the only time a fraction can equal 0 is when its numerator equals 0. Does 3 equal 0? Not in our bond system. All right. Does the denominator equal 0? Well, can you set that equal to 0? It's ugly, but could you set it equal to 0? Yeah, and is it in a pretty good form to do that? Yeah. What would happen if you did FOIL this out? You get 9x squared minus 12 minus 24x plus 16 plus 1 is plus 17. You'd have to set that equal to 0, which then you have to refactor it. But wait, it's already factored. Let's keep it like that. Does that make sense? Remember that conversation? All right. Now, the next thing we talked about on Friday was, can you drop the 3x minus 4? Or the absolute value around the 3x minus 4? And the answer was yes, if that quantity is always positive. Because then the absolute value isn't necessary. Is 3x minus 4 always positive? No. It's a line like this, 3x minus 4 on its own. 3x minus 4 is a line, and it's not always positive. So you do need those absolute value symbols. This would be my final answer here. Do you see what I was talking about on Friday where a lot of students would feel like they didn't do enough in this problem? I just don't feel like I really did much. It's kind of plugged it into some wonky formula, right? That's my wonky. Use the word wonky is a good word for describing something off kilter. Wonky. All right. We talked on Friday about sine inverse derivative, tangent inverse derivative, and secant inverse derivative. And we said that's kind of weird, which a lot of you can relate to. It's weird because it's out of order, out of order for us. Does anybody know why we did it in that order? Well, let's take a look. Do you remember? Actually, you know what? It's TI Inspire time. Time to get inspired. All right. So, sine of x. Sine inverse of x, correct? And let's talk about regular sine of x. If you were to tell an Algebra 2 student, pre-calc student, to take sine of x and then transform it into cosine of x, the graph, just the graph, and then we'll talk about the algebra. What would you tell them to do to the sine of x graph to make it the cosine of x graph? Shift horizontally. How far? 5 or 2, agreed? While that calculator is loading. That's dead. Oh, did I make it? No, I'll get it later. All right. Sine of x. All right. Cosine of x starts at a height of 1. I'm off, but whatever. If you were to tell cosine of x to turn into sine of x, I said it the other way. Turn sine of x into cosine of x. Wouldn't you take sine of x and shift it left pi over 2? Do you agree? Okay, what about the inverses? I forgot to do that during trick or treating. That would creep people out, right? Wouldn't the inverses be a vertical shift if the regulars were a horizontal shift? So as you go to visualize sine inverse of x, let's go ahead and graph sine inverse. Tabs. I restarted. I thought of you guys.
Nice.
I restarted and I could hear my laptop.
Can we see the CPU?
I don't know if I'm ready for that yet. We're not far enough into the school year for you to see my tabs. Sine inverse. Anybody have issues with that graph?
It's a little wonky.
It is wonky. Thank you. What does sine of x look like? Domain? All real. What's the issue? The range isn't all real. Why not? It wouldn't be a function. Good. Okay, so the calculator and some books will define sine inverse as being different than capital S sine inverse. Okay, one is if it were the true inverse that goes on forever. The other one is the part that keeps it invertible. Do you agree this keeps it invertible? What does that mean? Where the original is a function and its inverse is a function. So as soon as it's like, I'm about to fail the vertical line test, you know what the feeling's like, right? You walk into a class, about to take a test, you're about to fail it, right?
Oh yeah.
That's what this one's going through right now. It's about to fail this vertical line test. It's like, I wish I would have studied more. No. And as it's about to go up, I'm just done. I'm stopping. Okay? I've had enough. I don't really need this in life anyway. Like, you get very introspective at that point. Okay? Where am I? Why am I doing this? No. That's what sine inverse is going through. And as soon as the tangent of that graph is about to go vertical, it stops to keep it invertible. That's why we didn't get too far into it, but that's why in our notes we stopped the domain from -1 to 1 non-inclusive, because if I were to include that point, the tangent would be vertical, the slope would be infinite, the slope would not exist, the derivative would not exist. You with me? Awesome, good talk. So that is sine inverse. How are we going to find the derivative of cosine inverse? Well, first of all, do you agree with this statement? Do you agree with this statement right here? This does not involve calculus at all. We want an empty pencil? 2/3 of an eraser. Cool. Do you agree with us? Why?
Because the inverse of cosine is negative sine, and the
Whoa, hold on. The inverse of cosine is negative sine?
yeah.
Not quite.
Oh, the derivative of sine, cosine is negative sine.
Okay, we're not talking about calculus yet. Purely graph. Ready? Sine of x and cosine of x are the same if you shift them left 5 or 2 units. If you shift sine of x left 5 or 2 units. Cosine inverse and sine inverse are the same if you shift it not left and right, up or down. Well, what is pi over 2 minus or negative sine inverse of x plus, right? You can write it either way if you allow for the signs, SIGN, correct? Isn't this a vertical translation of pi over 2? Are you with me? This is not a calculus statement. This is a pre-calculus statement. You don't have to write these down. I'm showing you where it comes from. Are you ready? It's time for calculus. What happens if I take the derivative of both sides? Well, if I take the derivative of the left side, that's what I want. I want the derivative of cosine inverse. We don't have that written down in our notes yet, do we? We want that. I want that. So, do you agree we can take the derivative of this side as well? Are you ready? What's the derivative of pi over 2? 0. What's the derivative of sine inverse? And it's the opposite of that. Well, it's not 1 over the square root of 1 minus u squared times du dx. It's the constant multiple rule. Are you ready? Opposite of the derivative of sine inverse. Some of you are giving me that like weird, I have no idea what you're doing look. Check it a lot. Okay? Help me out.
So the derivative equation of cosine is just negative sine.
The derivative of cosine inverse of u
It's just negative sine.
is the opposite of sine inverse of u's derivative. So on Friday, when we wrote down sine inverse's derivative is negative 1 over the square root of u squared minus, 1 minus u squared times d dx, we have a new rule. The derivative of cosine inverse of u is negative 1 over the square root of 1 minus u squared times d dx. What does that mean? What are the implications of that? Come on, guys, you got this. It's Monday. Remember on Friday, you said it's Friday. Can't have 40% of the week lost. Go find your own tabs. Guys, this is great news. If you have sine inverse memorized, its derivative, you got cosine inverse's derivative memorized. It's the opposite. It's negative. Opposite. Yes? This is fantastic news. Well, let's keep going. We haven't learned cotangent inverse yet, have we? Good news.
Let's go.
What's the derivative of pi over 2? What's the derivative of negative tangent inverse? Well, not positive 1, negative 1 over 1 plus. Did I write u squared plus 1 or 1 plus u squared? 1 plus u squared. Times du dx. Ooh, that's nice. Well, wait, we don't have the derivative of cosecant yet. Cosecant inverse. Good news. Great news. Negative 1 over absolute value u times the square root of u squared minus 1 times du dx. Now, This came from pre-calculus ideas of just a shift, a vertical shift. And then we took the derivatives of those. Okay? And I can hear your thoughts. Some of you are like, just write them down. Don't tell me why. I don't need to know how hot dogs are made. You just ruined it for me. Challenge yourselves. Make sure you guys are trying to figure out why this works. All right? Get the full experience. Because of what?
Because of
Math. Math. So, if you are a person that likes to rewrite your notes, write them all down. You could write out all 6 right now. You could write derivative of sine inverse, 1 over the square root of 1 minus u squared times d dx. Derivative of cosine inverse, negative 1 over the square root of 1 minus u squared times d dx. Derivative of tangent inverse, positive 1 over 1 plus u squared times d dx. Derivative of cotangent inverse, negative 1 over 1 plus u squared times d dx. Secant inverse is derivative. Cosecant inverse is derivative. Does everybody understand? Does everybody have them written down correctly? Don't make the mistake of writing them down incorrectly and then practicing them. Let's practice. Bless you. I went to this one house yesterday, trick or treating. They had like a balloon arch, and then they had like a table with like crock pots plugged in, and they're giving out hot dogs and like hot apple cider and coffee. I had like a photo booth to do this. I told my kids, Reese's cups, thanks. This is your bowl. Reese's cups, thanks. I get 20%. But Dad, I drove you there. Nothing said that idea. Tony, you got this?
Yeah.
What is it?
I got negative 2x over 1 plus x to the 4th.
You guys agree? I agree. You ready? Let's do that 21 again. 21 from the homework. Y equals tangent inverse of the square root of x squared minus 1 plus cosecant inverse x, where x is greater than 1. Bless you. Ooh, this is a tasty one. Oh, it's spicy. Bless you. What's our favorite Halloween candy? Reese's. Why wouldn't Dairy Queen keep the Reese's out of this blizzard? They had Reese's Pieces and Reese's Cups in it. Like that's a can't miss unless you have peanut allergy. What are you saying? You just messed me up, okay? They're getting soft on us. Soccer, we feel like we played well on Saturday.
It's alright.
All right.
They're the better team.
Football.
I don't think they were very good, but
Western.
yeah, Western.
What's that? Is that outside of Columbus? Or? Was there cross country this weekend?
Just reach.
Just Ian was the only one that was running.
Huh?
Ian was the only one that was running.
How'd he do? He didn't. Did you guys get that far? I'm getting blank stares. All right, let's go through it. Ready? Tangent inverse. It's 1 over 1 plus u squared times du dx. The derivative of this is a chain rule. 1/2 comes down. Leave the inside alone. Subtract 1 from the exponent. Times the derivative of the inside. Yes? Yes. Let's take that first part. We got x. I'm going to do a couple steps here at once. Ready? This x stays up top. This term goes down. It becomes x squared minus 1 to the positive 1/2 once it has gone down. Times this guy. 1 plus, what's this guy? What happens when you square a square root? See what's inside. Just like a piñata. I don't know where I was going with that. Yes? Let's keep working. This is going to turn into plus a negative 1 over really not much to do over here. Nothing to see here. Nothing to see. Until later. You ready? We got x over. I'm going to write this as the square root of x squared minus 1 times x squared minus 1 over absolute value x times square root of x squared minus 1. But wait. We don't need the absolute value around that anymore. Why not? Up top it said x is always greater than 1. X can't be negative. Not negative. Don't need an absolute value. That was special for this case. Would you leave it like that? I wouldn't, because I want this as one fraction. Because it's we're going to need to set it equal to 0 and find out where it doesn't exist. Let's find common denominators. It's not that bad. Are you ready? All I need is another factor of x over here. But if I multiply by a factor of x down there, I have to do it up there. Come on. You ready for this? Ready for this?
Yeah, I'm ready for this.
I can just picture a mosh pit in here. You guys know what a mosh pit is? Is that still happening? Is that still happening? We weren't allowed to play the song Sandstorm at our dances anymore. There's a mosh pits. You guys know Sandstorm, right?
Yeah.
Darude. Who doesn't know? We'll have to play it for you. I'll get you hyped up for your homework tonight, okay? Play some Sandstorm. Final answer? Boom.
Oh my gosh.
Boom. 0. Aren't you just curious? Aren't you just curious? What does that mean? Let's graph it. Oh, come on. Who's saying it? Is that Dom? What are you talking about? It's not that deep. Have you ever been to the Grand Canyon?
No.
Have you ever been to a tall object? You say it's not that deep?
Yeah. I don't see why we gotta graph it.
You say Mariana's Trench? 7 miles deep? Shallow. Okay, kiddie pool. Compared to this.
Oh my god.
No. It's actually a tangent inverse. Boom. Caden hates me. All right. She said it was a sign. Like. I should think I should really think through some other occupations. What else could I do? What else could I be marketable at? See, nothing. Ooh, here we go again.
Whoa.
Shallow.
Shallow.
That's a one. That is one. Thank you. Is that Tyler? Was that you, Tyler? Was that you?
I didn't say a word. I have no idea what's even
I
happening.
thought you said it was wonky.
Luke said it
Is
first.
that Luke? Thank you, Luke. I knew you were on this week. That is a wonky graph. That's the original. What's the derivative? Always 0?
No.
Only when x is greater than 1. Correct?
Yeah.
So we did actually I guess we did some special math that was only applied to when x is greater than 1, right? We dropped the absolute values. We're only allowed to do that for x greater than 1. It would not have worked over here. Interesting. We good? All right. Homework for tonight. What?
Tabs. It just looks like there's not many. Oh, that's not bad.
There you go.
That's pretty normal.
There you go.
That's normal.
There, my three preps: honors, geometry, algebra, AP Calc.
I'm proud of you. You've improved.
Comfortable tabs.
Huh?
You've improved.
Thank you. I restarted. I restarted my tabs.
Yeah.
We'll see.
Restart right now. Restart right now.
I don't feel comfortable with restarting right now. All right, there's your homework for tonight. I guess when I say none this week, I guess small quiz tomorrow. Canvas quiz. Just derivative rules. Through section 3.8. So I would ask you, now you have to be able to understand the chain rule applies to all of these. If I said, what's the derivative? Listen carefully. If I say, what's the derivative of sine of u with respect to x? You wouldn't just say cosine of u. Do you understand? Cosine of u times du dx. Do you agree? Because u is not just u. U is a function of x.
Is it multiple choice or you have to write
Why don't I take a look? I'll take a look.
it?
I'm forgetting the format.